Okay, in last session, we seen the modeling of mixed compression supersonic intake system of Ramjet engine, and we seen the analysis of mixed compression supersonic intake system. Now, in this video, we try to see how we can see the result tab in ANSYS fluid flow fluent on the mixed compression supersonic intake system. By default, after setup, the solution is given green color tick mark. Now we try to open result window. When you double click on result window, so this is our result window. You can see here. Now, so in default, at the left side, we have a whatever named sections we created in the mesh, those are imported it here. If I select axis, so axis is going to only highlight. If I select inlet, inlet will is going to highlight it here. And if I select outlet, outlet is going to highlight it here. You can see clearly. Okay, so this is your inlet, this is your outlet. If I select wall, so it will going to highlight. Okay, you can clearly visualize the inlet, outlet, and walls are going to visualize in result window. What I try to do, if I select periodic, okay, so this is my periodic, so total surface is going to select. But the other side, it was halo, so there we have a periodic shadow. Okay, there is a complete geometry was selected. Initially, actually, whatever we see in starting before geometry creation, we made it to 2D analysis. For visualization, it is given some thickness here. Okay, so what I will try to do, I will try to deselect all the surface body here. Then, so first at the top, I have a contour. I will select contour. I will give name for my contour is pressure because I want to plot for pressure. So I will be selecting a pressure. Okay. Okay, it is saying it is already existed. Please use a different name. So what I will try to do, I will use a different name, pressure 2, because it is saying pressure is already exist. I will select pressure 2. Okay. Now it is asking location. I will try to give periodic. So here I try to visualize pressure on the periodic. That is the total surface of the geometry. Here I will select contours are 500 and I click on apply. Okay, see, this is my pressure contour. Okay, in setup we are unable to see clear shock waves, but here you can see in the result window we can clearly visualize shock waves. Our oblique shock wave. This is oblique shock wave. It is starting from the first ramp, so it should exactly touches with the cowl. Okay, then only it will going to reflect inside, and at the exit we will be having higher pressure. Okay, at the exit we definitely need a higher pressure. So according to that, we try to adjust our oblique shock wave, which exactly will touches it here because see some shock wave is passing away from this cowl. It should not happen. We try to adjust in such a way that it should exactly touches with the cowl tip. Then it will reflect inside. Then we'll have a highest pressure at the exit. Okay. Then this is our pressure contour. Then how suppose I need pressure at the end point. How I will try to do? At the top I have a probe option. So I will go with a probe. I need a pressure at the particular point at here. Okay, so I will select a probe at here. At the bottom, I have a probe location, X, Y, and Z location. I will select pressure. So the pressure at this portion is minus 45010.5 pascals. If I need pressure at this portion, I will click it here. Here it is showing pressure value 130653 pascals. So this is how you can obtain the pressure wherever you want. Okay, you can have your pressure values wherever you want. And similarly, instead of pressure, you can select velocity also. I will select velocity. I can have velocity value at here. You can see this is 763.234 highest velocity. Here we will be having lowest velocity. You can see 610. Okay, this is how you can obtain your pressure and velocity at particular location wherever you want. Now, so this is my pressure contour. Then I'll go with another contour here. At the top, I will click on contour. I will be giving as a velocity 2. Okay. Now it is asking again location. I will select periodic. Then instead of pressure, I will select velocity. Number of contours are 500. Then I click on apply. Okay. Even though if we see clearly, I apply. So the pressure and velocity counts are merging together because in the same periodic I represented velocity and pressure. What I try to do, I try to off my pressure. So I will deselect pressure to such that you can see only velocity. Okay, this is my velocity count to the highest and lowest velocity you can clearly see from this velocity count. Then if I need density, again I will go to contour. I will mention density to okay. Then here I will mention periodic one. Instead of pressure, I will select density. Number of contours are 500. Apply. Again, velocity, density as merging together. I will try to deselect velocity. Now you can see only density. You can see this is the oblique shock wave which is going away from the cowl. It should touch us exactly at the cowl. Then only we'll have a highest pressure at the exit. Okay. Now, so I want to deselect all the contours. Now, what I try to do, I try to see fluid flow behavior. So at the top, I have a stream line. So I will click on OK. Now it is asking me start from. I will select inlet and default it will go to outlet. So I will add number of streamline points are 500. Click on, I will go with a direction forward and backward. I will be selecting direction is forward and backward. Click on apply. Now you can see these are my streamlines. Okay. When you zoom, you can clearly see the streamlines are flowing away your cowl and ram. Suppose these are not convenient, I will go with a 50 streamlines. I click on apply. You can see these are the different streamlines. We can clearly visualize now. Now I want to see fluid flow. At the top, I have a animation option. You can see animation option. When I click this one, it is a default. It will having a streamline because we already created a streamline one here. So I will make it as a somewhat slower. Then when I click on play button, you will see. So this is how your fluid is flowing away from your mixed supersonic intake system. Okay, this is how you can see your fluid flow onto the over to the mixed compression supersonic intake system. Now, what I try to do, I will try to stop here. Now, I instead of 550, I will increase 500. Click on apply. I will be increasing streamlines. Now I will play. Now you can see clearly. Okay? So this is how we can visualize fluid flow. Still, I need somewhat slower. Okay, this is the fluid flow behavior. Now we have different options also. We can make it continue for a different time period. After that, what I try to do, I will deselect again streamline. Now, what we try to do, okay, we will go to location. In location, we try to create a line. Okay, so I will be giving as a center line. Okay, okay, in center line, I try to give a location for my line. Okay, with the P1 minus 0.81851, 0.04. So that is the starting point at here, and the end point is 0.51457 x value at here, and y value is same 0.04. So this is my line I was drawn from the starting to end point. Whatever I explained in the last video. So this type of line you try to draw and you need to identify the coordinate points. Okay. Now what we try to do, we will so when you click on apply, okay, we try to click on apply, and if you want, we can add number of samples here. I will be adding 100. There are 100 points are there along this line. Now what I try to do, I will try to right click on center, insert. Uh, now so you can insert streamlines, and you can insert legend. Okay, we can see different values onto that this horizontal line. What I try to need, I need a plot along this line. At the top I have a XY plot or chart. Okay, I will click on this one. So it is asking me to name chart. uh, okay, I will click on OK. Now it is asking title. So I can give pressure versus center line. You can take whatever caption you want. Then data series. It is asking location along this center line. I need. Then x-axis should be chart count only. Whatever 100 I given. Y-axis it should be pressure because I given here the title should be pressure. So y-axis is a pressure. Then I will click on apply. You can see. So this is the pressure graph. So from starting, the pressure is increasing, but at some portion it is decreasing. We need actually the pressure should be increases continuously from the inlet to the outlet. This we need to achieve. Then, if I want to instead of pressure, I need velocity. Go to general. There, I want to change velocity. Then in x-axis, same chart count. Y-axis, I will try to change to velocity now. Again, I click on apply. You can see this is your velocity counter. So the velocity is maintained constant before the mixed supersonic intake system. At here, the velocity is decreases, and at some portion at the inlet, it is increasing. So we try to avoid this increasing by changing the inlet and exit pressure of the mixed supersonic intake system. Okay, this is how we can plot our x and y velocity. Okay, with this, we finish with modeling and analysis of mixed supersonic intake system of a ramjet engine. Okay, thank you.